Hey everyone, welcome to our second episode of our totally reliable delivery service update. Today I have with us a special guest. We got Zach from the devs team. Hi Zach.
Hey, how are you?
Pretty good. Anyways, today we're going to tackle networking with Zach, what our team's done to improve it, and what kind of steps they've done and tools they've used to get it where it's at today in this update that we're going to be releasing soon. So, all right, Zach, let's start off with Photon Unity Networking. Now, I've heard this phrase a bunch tossed around. What is Photon Unity Networking, and can you unpack that for us?
Yeah, totally. So, in order to bring our game online, we have a Unity-based game. Unity is our game engine. We need to write a bunch of code to connect everybody's computers and sync the game experience between everyone across the internet. And Photon is a library. It's a tool available to Unity developers like us. And it's also a service that handles a lot of the online servers and networking. So we were able to use Photon as a tool in our game in order to, as a base basically to build our online experience off of, and it's been great. So all of our kind of optimizations have been kind of on top of that Photon starting point.
Awesome. All right, so our next area that we want to talk about is interpolation improvements. Now, yet another jargon that I have no clue what it's about, but I just know you guys have been working tirelessly at it. Do you mind breaking down what interpolation improvements are, what that means for the players, and just any examples we have for them?
Yeah, sure. So interpolation is basically smoothing from one position to another. So if you imagine the helicopters flying through the game, it needs to get from A to B. Well, over the network, you've got two people playing maybe on opposite sides of the world. We have to keep that helicopter going the same speed and keep it in the same place on both people's computers over the network. So there's delay there. And we want to make sure both people see a smoothly moving helicopter. Now, a game is at 60 frames a second, 120 frames a second. We can't sync data over the network between two players that fast. We might only be able to do that 15 times a second. So interpolation lets us smoothly move, a helicopter or a player from A to B, even though we don't have smooth updates on its position every frame like you would if you were playing locally. So we're able to kind of guess and project what that movement looks like between these network sync updates. And there's a lot of different ways to do interpolation. We actually made a test scene that has bouncing cubes, and it shows different methods of interpolation, like how you could do it. And some are better at some things than others. We went with an interpolation that first, smoothly moves a moving object, along a path in between these network updates. But then on top of that, it does another smoothing that in case the updates are super variable because maybe you've got a connection problem, it actually smooths the difference between two smooth updates to try and keep it to be the most smooth it can possibly be.
The most reliable, would you say?
Yeah,
totally reliable networking solutions here.
Totally reliable networking solutions. We should offer our interpolation as a package.
Absolutely. So with the interpolation example we have pulled up here, the turds lerp clamped. What am I looking at with this? Is that what we ended up going with?
That was the original.
Okay.
Or either the clamped or unclamped ones you're seeing there are where we were at before. And then I think on the far right it says lerp plus lerp or something like that.
Lerp plus lerp and lerp plus continue.
Yeah, so lerp plus lerp is the one that we ended up going with. And you're basically, like I said, you're smoothing your best guess of a trajectory, but then you're also smoothing the differences between each change so that you don't have a jittery smoothing as the network changes. And you're actually able to potentially even look at the network to see if it's struggling and then increase that additional smoothing.
Oh, okay.
Because you don't want to just crank it up to 11, because then the game would feel kind of like you're on the moon. It would be a little bit like floaty, and so you really have to kind of dial in the right amount of correction.
Awesome.
And some of the other methods are really cool, but like are best for objects in continuous motion. Like if you were doing like a racing game with like a car on a road, it's a lot easier to predict movement based off of acceleration. But when you have characters that are full ragdoll physics, some of the predictions don't work so well, because you're potentially guessing at the player going someplace that's like through the ground or up into the sky. That's not realistic. So we had to pick one that was more realistic.
That makes sense. Like just having like more physics-based interactions, needing something different from the networking and making their own problems. Awesome.
Yeah.
Well, then moving on to the next and our last segment of this interview, let's talk about compressing network data. So I heard something around 50% compression, you were saying. Does that sound accurate?
Yeah, so I was able to get our network data down about 50% from where we were at. With, Photon, if you just need to send a simple like yes, no question over the internet, like is somebody wearing a hat or not? I mean, this isn't a real example, but if you just have that kind of yes, no question and you need to send it over the network so that both computers see the same thing, without optimization, that's potentially taking 8 times as much data as you really need. Because for every one of those yes, no questions that you have, you can potentially answer 8 of them in the space that it would usually take to do one. And this is, technical stuff, but it's how the internet and computers work. They send what's called a byte of information over the network, and inside of a byte are 8 bits, and each bit is a yes or no question. It's a 1 or a 0. So when you have something that simple, you can really pack a lot of them into a little bit of data. And the other place where we got this giant 50% savings, which has really improved the smoothness and responsiveness of the online game, is, every time you want to have a helicopter or a player or a package appear in the same place on 2 computers over the internet, you have to say 3 pieces of information for where it is. It's X, Y, and Z position in space, we call it. So that's 3 pieces of information.
Okay.
And then you also have to say how it's rotated in space, because we have a physics game, so the player could be laying on their back or flying through the air doing cartwheels. And so that rotation is another 3 pieces of information. And
wow.
So it's a lot of information, especially in a 4-player game, that we're constantly having to sync. It's called NetStack. This tool helped us improve upon Photon. We use NetStack, and that has built into it compression things for rotations and positions. But I was able to actually do even better than that, because if you look at the size of the game world, you can actually determine like the minimum number of bits of information that you can use to represent the space that the player can play in. And you can actually do a little bit better in your compression. And also I was able to put in some intelligence that looks at all of these rotations. And if an object, for instance, like a wheel on a vehicle, can only spin in one direction, in one axis, then I can intelligently say like, ignore that data, don't send that data. And so that's potentially like a 66% savings.
Wow.
To just say, I only care about one axis.
That's all I got.
I would just say thanks for interviewing me, Tony, and it's been really fun.
Yeah, it's been great working with you, and I'm excited for all of this stuff that we've been working on and have coming out in this big push we have coming up. Thanks everyone for listening to me and Zach talk about networking. If your brain hurts, don't worry, mine is absolutely gone as well. Check the link below for the Steam store. We'll be hitting Steam pretty soon. See you guys.